All right, Mr. B, we're back.
Let's do this, man. I'm ready to talk about chemical and organic sedimentary rocks.
Oh, man, a lot of stuff. So take a look at those learning targets 21 through 28 and make sure you revisit those as we go through the slides and then definitely at the end so we're just on pace that you can do all those things.
Yeah, and pause it, and while we're talking, if you're kind of trying to figure out what we're talking about, go back towards the targets. See which targets relate to which of the slides. I mean, absolutely pause it. Make sure you keep going back to these targets. Okay, let's hit this. So, first, chemical sedimentary rocks. What is a chemical sedimentary rock, Mr.
Yeah, that's really good. Well, it was a chemical process definitely produced it. And we think kind of where we've come thus far, we've talked about the sedimentary environments, and then Mr. Watt and Mr. Bennett talked about the detrital or clastic sedimentary rocks, where they're actually made of those pieces of broken rocks, cemented or compacted together. But these chemical sedimentary rocks aren't really made of other rocks. They're actually made of crystals.
Yeah, and they're really similar to kind of minerals because they're formed basically of crystals. I mean, what's happening is we've got some kind of solution that's got something dissolved in it, and at some point it can't hold all the dissolved load, and it starts to crystallize, or it's set into a crystal by some other process.
Yeah, exactly. And it's not really set by lava or magma or anything like that because its origin is not. That would be more igneous rocks, and now we're looking at sedimentary rocks.
Okay, so for the first type of chemical sedimentary rocks, we're talking inorganics. Okay, so we're talking about inorganic meaning something not from a living being.
Exactly.
Okay, so some examples that we see are mainly the evaporites. We see speleothems, which would be found in caves. We see salt flats.
Yeah, those are out in Arizona, Nevada, out that way.
Arizona, Nevada. If you're interested in high-speed racing, they go out to the salt flats.
That's where they've broken all those land speed records out there.
I'll get the foot speed record for myself. I'm really fast. And we also talk about inorganic limestone, so just calcium carbonates that are formed from a non-living organism.
Yeah, because there's a lot that are formed from living organisms that we'll get to later on.
Okay.
All right, moving on.
Next one, we had inorganic. Now we've got organic. So things from life.
Living things, exactly.
So we've got sedimentary rocks formed from living things. So we've got a couple different types. We've got some coral reefs, which we saw before. If you take a look at that picture, we've actually got some coral reefs seen on the yellow and the green. And then in the middle, the purple, that's like a sponge.
Yeah, exactly.
Okay, so what they're doing is they actually filter out a lot of the carbonates from the water, and they set that kind of as their skeleton.
Yeah, and they grow, and they get bigger, they get larger, and take in a lot of that calcium carbonate. And that would be in a shallow marine environment, because that really looks similar to the picture we saw with all that life, right? With all those fish and plants, etc.
Yeah, and then we've got coquina. Basically, if you look at it, it looks like a bunch of broken shells.
Yeah, exactly.
And they're cemented together somehow.
Yeah. So just like sediments would be, just kind of falling down to the bottom, like in the ocean when they die, they just kind of build up on top of each other.
Yep.
And then they get cemented together.
Okay, and then the last one is chalk. There's a picture here of the White Cliffs of Dover.
You were there, right?
I got to go this summer. It was really cool. It's basically an entire cliff face built of chalk.
Huh, that's cool.
And all that chalk is organic. It's built from these little, they call them diatomaceous organisms. And they're all little organisms that basically take in dissolved salts dissolved materials from the sea, and they set them as their skeleton structure.
Got it.
Yep, and that's chalk.
Cool.
Okay, so we've got a little demo on these speleothems. This would be one of the inorganic forms of our sedimentary rock. All right, so if we take a look, we've got a whole bunch of different just voids in the rock here. Okay, and these voids in the rock are starting to fill with water.
Yeah, and we can see that the level of the water inside of these now kind of caverns or these void spaces is kind of following the level of this river that we have over here on the far right-hand side. So if we take a look as we go through the slideshow, we'll see that water level start to decrease.
And we're actually starting to dissolve some of the limestone. That's where we get the caves that start to form.
Yeah,
so we dissolve the limestone as water's washing through it. Okay, so we're just going to kind of play through and take you through a couple different steps. Okay, and as we get some rain and it's starting to dry out, the water table starts to lower. Okay, so just like Mr. Z said, we've got the water table lowering here. Same thing happens in the caves. Okay, and then it gets all the way down, and then Mr. Z, what's going to happen next here?
All right, so as you can see, we have all these void spaces that have now turned into caves, and we have a lot of these. If you look really closely at the animation, we have a lot of like stalactites and stalagmites inside there. And how do those form? I think it has something to do with definitely the rainwater from up above starts to percolate through the porous groundwater, and
well, basically, as you got rainwater going through the rock, the limestone there,
Yeah.
it dissolves a little bit of the rock, and as it dries or as it drips, it leaves a little bit of that dissolved load behind.
and it kind of adds to it, doesn't it?
Yep, and it builds it. And so if you ever go to a cave and you see a stalactite, which stalactite is on top, stalagmite's on the bottom.
Tight to the ceiling.
Tight to the ceiling, okay.
Stalagmite might trip and fall.
Nice, I like that. Okay. And so what happens is if you see it dripping, it's actually building at that
Yeah.
point. Each time it drips, you lose a little bit, leaves a little bit of that dissolved load behind. Okay, and it starts to build it. When it drops on something, it leaves a little bit behind on the stalagmite.
Exactly.
Okay.
And then once those two connect, the stalagmite and the stalactite, I believe they call that a column.
They call it a column, yeah. Okay. So let's jump back to the slideshow.
All right, we're back. All right, so now we're going to look at some specific chemical sedimentary rocks, just like you guys did in the previous segment with the clastic and detrital rocks.
Okay,
All right,
so this first one we got some fossiliferous limestone. So
right.
fossiliferous just means that it's limestone with fossils in it.
Yeah, exactly. And we can actually see those fossils in the picture. We can see fragments of shells and coral, etc. They're all kind of like glommed together in there.
Okay, and so it asks how would we test for this rock in the lab to identify it? Well, first we got to see fossils.
Yeah, definitely.
Okay.
And then we would see if it reacts with HCl.
With hydrochloric acid, because the carbonates in the limestone react with the hydrochloric acid.
Yeah, and what does that reaction look like?
It's just fizzing.
Yeah.
Fizzes up, it effervesces, they call it.
Effervesces, yeah.
And it gives off a little bit of carbon dioxide gas.
Yeah, kind of smells funny.
Yeah.
Yeah. And then what type of environment would we see this?
We would see it in a shallow marine.
Yeah, definitely, right? Where
Yeah.
we saw all that life in these last couple of pictures here.
Yep. And then we got chalk. Chalk, again, what type of environment? We're looking towards that shallow marine again.
Exactly.
Okay. And one of the ways to test with this is basically you could write on the table with it. I mean,
Yeah.
it behaves like chalk. It's really soft. You could scratch it with your fingernails. And also, if you did hydrochloric acid, it should fizz like crazy.
Yeah.
Okay. And actually, one of the things, the chalk that we use on our chalkboard really isn't chalk. Sorry.
No?
If you put hydrochloric acid on it, it's gypsum.
Oh, man.
I know. The lies that your teachers have been telling you for years. You're welcome. All right, let's go to the next one.
All right.
Okay, next one we've got some dolostone. Now, dolostone is really similar to limestone.
Yeah, except it has magnesium in it.
Yeah, so limestone is calcium carbonate. Dolostone is actually calcium and magnesium carbonate.
Yeah, and the environment, I believe, is also shallow marine, and there's actually a lot of it out there in the earth, but scientists are kind of baffled in how that got there.
Yep.
It's a big controversy. It's called like the dolomite problem or dolostone problem. They don't really know exactly how that magnesium got in there.
Yeah, it keeps me up every night. So.
I know.
To test for this one, since it's got that extra magnesium in there, it doesn't react as much like
Yeah.
the limestone does.
Yeah, and you actually have to maybe even scratch it with your finger or powder it up a little bit, and then if you drop that hydrochloric acid on there, it will fizz, but it's not going to be as big of a reaction as you would see with just CaCO3 or the calcium carbonate.
Yeah. Next one we got is rock gypsum. Okay, rock gypsum. Oh, too fast. All right, there we go. The next one we talk about is rock gypsum. So now rock gypsum just is an environment that has a high gypsum concentration in the water, and as it gets too high, it starts to get super saturated, starts to form the rock gypsum.
Yeah.
Okay. The way to test this in the lab is it's not going to react with hydrochloric acid.
No.
And you have
It's
to
gonna
actually,
be-
you can scratch it with your fingernail,
Yeah,
right?
it's going to be real soft. All right.
Cool. Okay, next one. These ones are kind of cool. We got chert and jasper. Really similar.
Yeah, they are. And let's start with chert, the environment this formed in. This is also going to be shallow marine, and it's going to be very microscopic organisms. And they had actually like silicon structures.
Yeah,
right?
it's just like the limestone. The limestone takes a lot of the carbonates out of the water and makes
Yeah.
a skeletal structure. So do some of the cherts. They take out, and this time instead of carbonates, they take out silicon out.
Yeah.
And so they get this really silicon-rich, like ooze almost.
Yeah.
And they set it as their skeletal structure, and that's basically how the rock forms.
Yeah, and then jasper is just kind of the same process, except we have iron mixed in, and it changes the color of the rock itself. It has the same properties, right? But it's got kind of that like reddish or that like oxidation type tint to it.
And to test it in the lab, all you would do is it's really hard.
Super hard.
Yeah, Native Americans used it as arrow heads, right?
Yeah, exactly.
Okay, and it's got that conchoidal fracture.
Yeah, that means that it doesn't tend to break in any kind of one spot. It just kind of shatters. It's kind of random.
Yeah. All right, and then we got flint and agate.
Flint and agate.
Okay,
And
these ones should be pretty similar, right?
yeah, they're kind of the same process.
Okay, so flint is, again, it's just another variety of the chert that we saw. It's a
Exactly.
little darker, isn't it?
Yeah, it is a little bit darker.
Okay, same type of test. Super hard. It's got the conchoidal fracture.
Mm-hmm.
And then we've got agate. What looks kind of crazy in the
Yeah,
agate.
and it's kind of like a mixture of all of those, of like jasper and flint, and they actually, depending on how that marine environment changed, you would almost get like kind of like layers of those different types of rocks.
And we've got that super saturated silicious ooze that's present, and it's basically the settling and the creating the chemical rocks based on that ooze.
Yeah.
Okay. Okay, we got some rock salt here. Okay.
Right.
Right now it's winter outside, and we're throwing rock salt outside
All
to try
over
to
the place.
melt the snow, and
All
it's
right.
actually a chemical sedimentary rock.
Yeah.
Okay, so the environment for this one, think evaporates.
Yeah, so if we have just kind of a shallow sea that's like salt water, I guess you could say, and then we have evaporation taking place, that salt's going to have to go somewhere, and eventually it crystallizes and then just gets deposited there.
Yeah, and it basically grows crystals.
Exactly.
Okay. To test this in the lab to ID it, you never really want to do this one in lab as much, but if you taste it, it probably tastes like
It
salt,
would
right?
taste like salt, exactly.
Okay. And also it sometimes has that cubic structure to it.
Yeah, it does. It does, you're right, just like we saw in minerals.
Okay. Then we got coal.
So now we made a transition here. We're going to organic now.
Yeah,
So we're
organic
kind of
rock.
leaving the chemical sedimentary rocks, and now we're going to start talking about organic sedimentary rocks.
Okay. So coal, we all know is from like old plants.
Yeah,
They
dead plants.
basically take a bunch of dead plants, dead animals, make it so they don't break down, they don't decompose as much, and start squishing them together at some point.
Exactly.
Okay. To test this one in the lab, it's really dark. It's
Yeah.
always black.
Yeah, sometimes it's got like kind of like a shine to it,
Yeah.
right? It's kind of it reflects a lot of light, kind of got like a high luster, almost like glassy.
Yeah, and sometimes if you get really like basic forms of coal, like really early, like they look at peat is one of the
Yeah.
early ones. Like you can actually see plant
Exactly.
matter in it, plant
Yeah.
material in there. Okay. All right, so we got a quick video we're gonna show you guys. Let's just pop right into it.
A million years. Geologic units are formed during millions of years. An example of this is a coal bed, which starts with vegetation. At the beginning, a swamp is thriving along a coastline, accumulating thick layers of plant material. As the basin subsides, organic material piles up in the swamp, and sand is deposited near the shoreline. Over time, as sea level rises, sand settles out and the swamp is covered by a beach. If sea level rises high enough, what was once a swamp is now under hundreds of meters of water and mud. When the sea retreats, sediment that was deposited is left behind, and a new swamp forms. Hundreds of meters below the surface, pressure and heat combine to alter the buried plant material into coal, while the surrounding mud and sand are changed into shales and sandstones.
Cool, real simple,
All right,
right
yeah.
there. Coming from swamps, dead plants, dead animals. That's what we use to, power a lot of our electricity.
Yeah, exactly.
Okay. All right, and around the world, we actually have a lot of coal that's mainly found. All right, that was a real cool.
Yeah, that
quick
was
video.
Yeah, it was a great video.
Okay. So if we take a look here, a lot of the coal that's found around Earth, do you know where it is?
Yeah, well, at least in the United States, I know it's along the eastern seaboard.
Yeah. That's where the majority of the coal in the world is, actually.
Yeah.
We have a pretty big monopoly on coal resources around the world. There's some scattered around.
Yeah, and it was our main source of energy for a long time in this country.
Yeah. Okay, and it's actually fairly filthy. It's a dirty energy.
Yeah,
and
it
that's
is.
because you're taking old plant material and basically burning it.
Yeah, exactly.
So,
to
and
get that energy out.
You're taking plants that took millions of years to basically not break down, but to turn into the stone or into the rock, and you're burning it.
Yeah.
So you're releasing all that to the atmosphere. And if you even take a look, the red side, it shows the lower quality coal, and then the gray side is more of the higher quality coal.
Yeah.
So like if you look towards India, India has a lot of the high quality coal compared to like say Russia. Russia's got really low quality coal, just meaning it doesn't burn as efficiently, not as hot, doesn't make as much energy. Okay, limestone. We use limestone a ton.
Yeah, we do, and these are all the uses of limestone, and we can see everything from cement to carpet backing. A lot of stuff on here.
Yeah, we use it for making glass, iron smelting. A lot of our roads are built from it.
Yeah.
If you guys ever drive on a highway, most likely you're driving on some sort of concrete or cement.
Yeah.
That was from limestone.
Yeah.
And a lot of it's actually mined right here in Illinois. There's a huge mine, the Thornton Quarry.
Yeah.
Just south of the city on Highway 88.
Yeah, and you can see it from the highway.
Mm-hmm. Okay, and then we have a couple different chemical sedimentary rocks. The first one is drywall.
Drywall for gypsum.
Gypsum, yeah.
And then we have salt that we have already talked about. And then down here in this last picture is a coal. We could see the coal mine in the back there, and we can see the train cars there in front.
Yeah, and we go through an amazing amount of it. I actually have a train track that runs through my backyard, and every day you can see, dozens and dozens of cars of coal that just get trucked right into the city.
Huh, you should bring in a picture of that one day.
Oh, that'd be fantastic.
All right, mastery check quiz. So you definitely want to make your way back to the to your website and get to that quiz and take it. I'm sure they'll do great.
Yeah,
Mr. B.
and if you have questions on the quiz, go back and check out the video again, and hopefully you should get 100% each time.
Yep.
See you guys later.
All right, take care.